this demo session on cloud performance engineering and DevOps and SRE, site reliability engineering. Uh, I'm not sure if we have met earlier. We have done a couple of workshops in last 2 weeks, last 2 weekends. If we have met, it's good. If not, let me introduce myself, friends. My name is Roshan. I am with Isha from last 6 years. Overall, in IT, I am working from last 18 years. From last 10 years, I'm into the cloud Kubernetes uh, domain. I'm currently working as a principal SRE, principal site reliability engineering, which is equivalent to architect role. I started my career as a Java developer. Then I have been into various other SOOs. I have been into performance engineering for 6 years, been into the cloud architect. Still, I am my role overlaps with cloud architects as well. For 4 years, I have worked with multiple cloud. I have worked with 4 cloud hands-on, AWS, Azure, GCP, and OCI, Oracle Cloud Infrastructure. That's background about me, friends. Teaching is something I like. It's my hobby. I work full time, and this is my hobby, passion to teach. That's where I'm here. Okay, friends. So this is this demo. I'm going to talk about a course that, and I'll walk you through the course, how we're gonna plan it, and see if you can leverage this course. If you think it's benefit, you can get onboarded, right? So this is the agenda, friends. We will start with a question. Okay, I would like everybody to answer. We will talk about software development and deployment evolution. Uh, we'll talk about the course and what will I learn by the end of the course. Okay, and a Q&A. Just a quick introduction from your end. I would like to just get a pulse of my audience in a very, without spending a lot of time. If you go one by one, we'll be spending the entire time. So what I would like, everybody, please help me. Just mention your core skill. Let's say performance testing, performance engineering, or you are into DevOps, or you are into cloud support, right? Uh, if you're non-IT, please mention non-IT. And number of years experience will help me just to get a pulse of my audience here so that I can have my discussion in line with that. Could we do this quickly, friends?
You mean to say over the chat?
Yes, please, over the chat.
Yes, okay, yeah.
Okay. So Prisha, when you say QA, you are QA manual or automation, please highlight that. It's an important metric for me. I see performance testing, engineering, IT ops as well. Harshit. Okay. Okay, system admin, Mir. Perfect. Okay, I see 70% of my audience is from performance testing engineering background. There are some managers as well, QA folks, few IT ops, system admin. Okay, perfect. Thank you so much, everybody. Okay, so we'll start with the question, friends. It is not just for the performance engineers, it's for anybody. Okay, any software engineers. I'll just correct my slide here. Okay, this question is not just for the performance engineers, for anybody. Software engineers. Do we agree, friends, that this DevOps, microservices, containers, cloud, do you think these things are expected to know? these things nowadays. Apart from your core skills, if you're working on performance testing, engineering, you may be working on Jmeter, LoadRunner, Gatling, Locust. You may first be doing some troubleshooting in JVM, GC algorithm, uh, GC logs, heap dump, thread dump, or a database tuning. You may be doing that, right? If you're a QA engineer, you would be doing automation in QA, Selenium, manual. If you're into IT operations, you would be helping as a support for any production issues, right? If you're system admin, you will be installing things. But do you agree on these things that do you really need to know these technologies, these things in current scenario? Okay, I'm getting yes, yes, yes. Mala, Pradeep, Sandeep, Kotiada, Ari, Anand, right? Okay, I request everybody to be on mute so that uh, we can have this. Rahul, you can, your video is on. You might want to turn off. Okay, perfect. I see everybody saying yes, right? Perfect. So this is what I would expect, right? Because if you go for the interview, whatever, so any field you are, maybe this may not be exactly true for the, I would say, if you're a QA engineer, let's say, because QA engineers are mostly to do with the functionality. uh, they don't bother much, right, about the underlying infrastructure. They may not agree on this because they are mostly looking into the application, web application or API, the response code and all those things. But in general, we should know this, all these things, friends. Now, in the next slide, you'll understand why these things are important. These things are important because these things overlap with our software development and deployment evolution. You'll understand this, why these things are important. So if you look at this, friends, how we have evolved over the years from 1980s when the software industry started, right? First, and now 2025. If you look at the transition, if you look at the evolution, you'd understand why these things are so important. If you talk about the development process, like the SDLC model process, we started our work with the waterfall. Waterfall had a lot of issues. We'll just quickly touch base on these things, friends. What is waterfall? Anybody would like to quickly, friends? What did you do in waterfall?
Yeah, means from you can say requirement requirement definition, design, and testing. Every phase will do in sequence. So like
Sequence. So
yeah,
first development will start, and then once the entire development completes, we'll do the testing.
right,
Right? We are
right,
not going. First of all, whatever the requirements that we have gathered, all the requirements. Let's say think about Make My Trip or Flipkart. We'll first develop every feature, and then we will test it. That was the problem with this approach, because after 6 months of development or 8 months of development, we start to test, and we are facing issues which were not that cheap to rectify. Like if there's some architectural flaws, let's say after 8 months or 1 year of development, you got to know that the application is not scalable, let's say. What would you do? How can you go back and re-architect things easily? Right? It's so expensive process. So it did not fly, but we learned. That's how we started. As a human, we all started like this. We were all here, right? That's how we started. We learned from our mistakes and then we moved to agile. What did we do? We split the development into phases. Okay, we will develop one module first, one functionality, set of functionality we will develop. If I talk about Make My Trip application, we will develop launch page, registration page, search option. That's all. That's our phase one. We will test it thoroughly. All sorts of testing, functional, performance, security, UAT, every testing we will do, and then we'll deploy the code to production. So we did in phases, and it's still applicable. Agile is still we use. So we split the development into phases, and we also took the feedback from our clients. I'll just take a minute, friends. Let me just draw this simple diagram. Okay. So think about this is the software development, right? You whatever the feature that you have, hundreds of modules, hundreds of features, you developed everything in waterfall. Once you developed everything, you started to test. That was the problem. Because some problems like scalability or which is not easy to fix. It was so expensive to go back and fix those things in waterfall. So then what did we do in agile? We split this into phases. Whatever all the features, let's say if you had 10 modules, 10 features. So we'll split this into phases. Phase one, phase two, we call this phase one. I'll take this in phase two. This is phase three. We split the development. Phase four, phase five. We split this development into phases. And we did all the SDLC process, development, testing, all the testing. So what did we do here, friends? We split this into phases. Phase one, phase two, phase three. Only one feature. We will test, we will develop it, test it, deploy it. And then we will also take the feedback from the customer, from the client. We'll take the feedback also. We'll incorporate the feedback in the phase two. Again, we will do all the SDLC process, development, testing, and then again we'll deploy the code to production. So this is the agile process. It's much better. Our end goal is going to be not a surprise thing. It's going to be very much in line with the customer expectation. And in this case, because we cannot take the requirement in between, the overall outcome may not be the same as what customer would have liked, right? Because there was no continuous feedback option here in the waterfall. But in agile, there was no such problem. We got what we expected. The customer got what they expected. End goal, right? So this is agile. Now, there is a problem with agile also. A lot of manual steps. Think about it. I would like to ask one question, friends. When the code is ready, friends, what is our end goal? What do we want to do with that code? End goal, I'm asking.
Yeah, it should be
What do you
deployed.
think?
It should be in production. And
We would like to deploy the code to production. That's the end goal, yes. But we don't want to take the risk, right? That's why we do QA, functional testing, performance testing, security testing, UAT testing. We do all sorts of validations. If these things are done manually, think about it. Code was ready and you deployed the code to production, and you're doing all the manual steps, how long will it take? Quite significant time. Do you all agree on this?
Yes.
Think about from the organization perspective. Let's say if you own a company, don't you think you would try to optimize this process? You first thing you would say, hey, let's automate it. Why you are doing manually, friends, right? Everybody, why we are deploying manually? Why you are doing testing manually? Why can't we automate the testing process? Why can't we automate the deployment process? Why can't we can schedule one job after another? Let's say when the deployment completes, code gets to QA environment. Why can't the QA testing could happen automatically? Why can't we write a Selenium script for the functional testing? Okay, once the functional is done, why can't a performance job could run in an automated fashion? We can integrate that with Jenkins. Security testing, same thing. Why can't we do this? Okay, if it fails, we'll roll back. We will let the team know. We'll create the issue. We'll let the developer know. But if it's automated process, will be much better. We can streamline. We can make the process swift. So that's what DevOps focused on. Okay, so DevOps is not it's same as agile process, but bring in automation. To agile, just bring in automation. That's what DevOps does. DevOps is coined from two words, development and operations. So DevOps talks about the better collaboration, how the development team and the operations team, how can they collaborate better? Dev and ops, how they can collaborate better to make the process swift. That's what DevOps focuses on. And that's what we are doing right now in this from last 15 years. A lot of companies, they're agile, but nowadays every company is into DevOps. Everybody, whatever the team you are, we have to know about CI/CD pipeline. If you are a performance team member, you will be creating job, which will be part of organization CI/CD pipeline, right? If you are into automation engineer, again, you would be involved into why can't once the code is deployed to QA environment, we should have a process of automatically triggering the Selenium jar file, right? We can do this. So that's what DevOps focuses on. So this is the evolution, friends, on the development process. Similar evolution has happened in the application architecture. Earlier, we were working on monolithic applications. Monolithic. What is monolithic means? Mono means single. Lithic means big. Single big unit. Think about one application, let's say, friends. I'll give you a simple example. Let's say make my trip. 1 second. Okay, take this simple example. Friends, you have so much of modules here, flights, hotels, homestays, villas, right? We have so many modules, so many modules you have. This is the front end part. So think about any web application. You have a web server. This is the UI part, web. Whatever you see is coming from the web server. They are rendering the web page, HTML page. When you click on this, the request hits the application server. And then application server hits the database server. Let's just think about the 3-tier application: web server, app server, database server. When we talk about monolithic application, we are focused on the application server, the backend logic. So what happens when you click on search? Let's say, take this simple example, make my trip in the flights module, Delhi, Bangalore, this date. Click on search. What happens? In the backend, friends, when I clicked on search, API call was made to all the flight carriers, Air India, whatever the display you see, API call was made to all the flight carriers. They would have responded in XML or JSON in different format. Then make my trip would have taken the response, passed the response, again passed it and displayed in a human readable format. The response what make my trip received was a very different way, XML format or JSON format. But they have written the code and to display like this. So a lot of things happen. A lot of things happen. Similarly, when you click on go to other modules, hotels, homestays, different calculation will happen. So do we want to host the backend logic in all one server? Do we want to deploy all the backend logic to only one server? Which is the better option, to segregate the backend logic code or to keep it together? What do you think? What's the better option?
Segregate, as we know, segregate has benefits. So now we
Right.
know that segregate. Yeah.
Right? We should segregate the code because we don't want if let's say, because mostly we use flights more often. Because of flights, we don't want other functionality to get impacted. If we have the same server, okay, I'll draw this, friends. I'm not sure if everybody understands this. I'll keep it simple for everybody here. So listen, you have the web server, display part. Okay, we are not talking about this. App server, where the logic is. And we have the database server. Focus on the here, friends, app server. When you click on flights here, or this is the display web page. All the web pages are together. Here, the logic, that's where the maximum logic happening, the calculation happening, processing happening. In the backend, when the request from the web server goes to app server, there we have the maximum process. Now, when you merge everything together, let's say flights, all the modules A, B, C, when you have all the modules put together in a single packaged together, when you package all the code base together, for all these modules, this is what we call it a monolithic application. Monolithic, big. And it's not good, right? Because if issue with flights, let's say a flight has more request, and I need more server for flights. I need more because that has maximum hits. I need to scale flights separately. Can I do this? Can I scale flights separately if I deploy all this thing together?
No.
We have to scale the entire application server. Even the other modules are not getting enough hits. And I don't want, because of one issue, other issue to get impacted. We don't want that. That's why segregation is important. And that's where, friends, we talk about the microservices. When you talk about microservice in today's world, it's all about microservices. We segregate it, we keep it segregated. The backend logic. We don't want one application to impact other application. And what is the benefit of this? If I deploy flights logic differently than the trains or whatever they have, I can, if let's say the issue with the flights, if you have some performance issue or some feature enhancement, anything to do with the flights, do you need to touch all the code base, or you will only touch the code base for the flights?
Just for the flights.
Just for the flights. If you are monolithic, you have to build the entire code base again. Even if you have made the smallest change, could be a cosmetic, whatever it could be, you have to build the entire code base if you're monolithic. That is the advantage we get in microservices. And all this current development is happening into microservices domain. On the servers, we have progressed over the years. Earlier, it was physical server. There were no virtualization when it was all started around 1980s. There were no virtualization also. Virtualization came early 2000 when we installed a virtualization software on this physical server like hypervisor, virtual Hyper-V, VMware. We installed this kind of virtualized software, and we could create VMs, virtual machines. We deploy most of the monolithic application in the VMs, web server, app server, database server in the VMs. It was a great revolution. Virtualization was one of the greatest revolution which optimized the cost because we were wasting a lot of resources in the physical server. Friends, nowadays we are not deploying on the VMs directly. We are deploying on containers. Do we know this? How many of us are like, I'm not sure if you have worked on, I'm just asking how many of you are aware that the application that you're working on is deployed in the container, not in the VM? Do we, right?
Yeah. Yeah. Like Kubernetes, right?
Kubernetes, yes. Yes, Swati, you have raised your hand. You can give me a thumbs up if you want to just say yes. If you have a question, you can raise your hand. This is hand raised, means you have a question. Just, I don't want you to confuse. Yeah, you can lower your hand, Swati. Thank you. Right, so we are discussing about, friends, containers and we'll discuss a lot about in containers. Okay, I'll discuss about the course and we have a lot of things, containers. I just want to give a brief. It's all about the cost optimization. Okay, keep it simple. It's all about the cost optimization. This technology from physical server to VMs, we moved because it was cost optimization. We are able to utilize the resources of the physical server efficiently when we move to VMs. Now, over the years, it has been observed that even the VMs are 20 to 30% utilized. We are assigning the servers to a VM. The VMs are 40 to 50% or 30 to 40. In the 30 to 50%, all the VMs are being utilized. So there's a scope. Why can't we make sure that the VMs are fully utilized first? Why are we wasting resources? Why are we creating new VM? If we have availability, oh no, I have a web server running, I have a app server running. I don't want to mix together, right? Because we don't have auto scaling things. I would like to run fixed number of servers, this kind of things. It's not like people are not aware. We are aware, but still we are doing it. So we have a better technology. It ensures that the VMs are fully utilized first. We create as many containers as its capacity. We make sure in the one VM we create a lot of containers first. The VMs are fully utilized. And then if you need another more containers to be created, you get another VM and then you get more containers. And it happens because of auto scaling. It will not happen like just like that you will get the VM. No, that the auto scaling has to trigger based on some criteria, CPU, memory, or network, or whatever, any metric. So it's all about the cost optimization. Okay, I'll not go in detail today, friends. It will be overwhelming, this technology. Just know that it's all about the cost optimization. And we are discussing nowadays, it's all about microservices being deployed on the containers. We deploy microservices. So we have made progress on the application architecture and on the physical server, the deployment and packaging. And when these two are merged, microservices, containers, and that's the best thing. We deploy microservice on the container and you get the best cost optimization. Now, on the data center, earlier, if you have a business idea, you have to set up a data center. If you are Amazon.com, if you're Oracle, if you're HP, IBM, you have to set up a data center to deploy your application. But nowadays, it's all about the cloud, right? We don't need to set up a data center. Setting up a data center is such a costly affair. Billions of dollars are required to set up a data center. I'm just starting up. Let's say a company is just starting up. If you put so much overhead in the beginning of setting up the data center, how can the company would do better in the beginning phase, right? So it's every company use cloud. They can get the servers, storage, whatever. Netflix, we all know, right? They use AWS. All the Netflix movies that you watch is hosted in AWS. The Dropbox that you use, they use AWS. Hotstar, they use AWS. A lot of companies, NASA use AWS, a lot of things, a lot of companies. So when you're starting up, all this Swiggy, Ola, Uber, all these applications that you see, they're using cloud. They don't have their own data center. Just when the business will grow, they can think about having their own data center. But it's easily, they can get the server storage within $10,000, $20,000 a month. They don't need to invest billions of dollars to get a data center. Yes, Pradeep, you have a question.
Yeah, so I'm just little confused about hosted and data center. Hosted, it means again on-prem.
Somebody else data center.
Okay, like third party vendors.
Party.
Okay,
Yeah.
Got it.
No, it's all about the cloud. Today, if somebody needs, what is the main difference, friends? Let's ask this question. What is the main difference between on-prem and cloud? What do you think? What's the main difference?
On-prem, whoever is hosting, they need to bear all the expense. Cloud, you no need to worry about the infrastructure or establishment kind of expenses. You can pay based on the utilization.
Right, very much. I'll just give you another perspective of it, just to make things little simpler.
It's like in prem, it is everything with the company or the the company manages everything, starting from infrastructure, software, installation, platform, everything. In case of cloud, it is optional which one you want, whether you want to handle infrastructure or whether you want to handle the software, and rest other things can be handled by the third party. Not third party, basically the cloud providers. So in case of cloud, you have an option.
Okay.
what to
Yep.
manage.
Perfect. Good. I'll just give a better simple example so that you'll always remember. See, whether you are on-prem or you are cloud, you need a data center. Data center is a common thing. I'm showing you a Google data center. All these diagrams. Think like a multi-story building in the outskirts of a city, multiple acres of land. If you are trying to create on-prem, so you have to invest all the things. You have to purchase the land, construct the building, purchase all the servers. This server will generate heat. You have to maintain the temperature of the facility. You cannot run out of electricity. You have to have multiple redundant power sources. You cannot run out of internet. You need to have multiple redundant power sources, in internet sources, ISPs. You have to maintain security of this facility. You have to hire security personnel. The servers may run out of order. You have to change some hardware also. You need to have some hardware engineers 24/7 in this facility. So a lot of investment goes into setting up a data center. Whether you on-prem or cloud, somebody has to do this. So it's only difference is that who owns it. If you own this or the company where you work, they own it, it's on-prem. But if some third party, they own like AWS, Google, Microsoft, if they own this data center, it's cloud for us. That's it. And we pay for what we use. We get some servers, we want like some storage, we need load balancer, we need databases, we need various features that they have developed. And we pay for that monthly. It's like staying in the rented apartment. We don't own the apartment, we don't own the flat. As long as we pay the rent, we can live there happily. We stop paying the rent, we don't own anything. In the cloud, right? We stop paying the rent, we will not be allowed to stay there. That's it. So it's like a rented service, cloud. That's the basic difference between on-prem and cloud, friends. So it's easy to get started in the cloud. All the company that you see, Swiggy, Ola, Uber, all these things, they're all hosted in the cloud. Okay, so friend, did we get a perspective why this DevOps, microservices, containers, and clouds are relevant? And it's going to be relevant. This is where this phase we are going in. And we are going from last 15 years. And we need to get onboarded on this. Okay, this makes sense to everybody? Yeah, OPEX versus CAPEX. Yes, Subramaniam, absolutely. Yes, Fustina, you have questions? You have raised your hand?
No, I'm sorry. I wanted to.
Okay, perfect. Okay, friends. So the course that I have come up with, right, I'm running this course from last 6 years now, and a lot of I have taught over a lot of people. I don't know the count, but yes, from last 6 years. So I'll just talk about the course, friends. Okay, this course we have classified into these categories. Okay, we talk about. I'll go to the link. I'll give you the link. Let me just. This is the link. I'll just walk you through this link. What this course brings, right? I'm going to give this link first of all to you. Okay, I have given the link. And let me talk about this. So friends, in this course, we touch on all these 4 things. We talk about cloud. We talk about AWS from scratch. That is the USP. I understand that my audience. Okay. Okay. Please go on mute, friends. Thank you.
Hi, sir. Hello.
Yes.
Hello.
Go ahead. I'm listening.
Yeah. This course, like it is a beginning from non-DevOps guys also they can start. No, this one
Correct.
They don't have idea in non-DevOps.
That's fine. Absolutely fine. You will. That's what I'm going to talk about it. If you give me 15 minutes, you will not have questions.
Okay.
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 Just Yeah, let me just complete this part. So friends, to get started, we talk about cloud. Okay, and we do it from scratch. Okay, I expect that my audience doesn't know anything about cloud. They are very much new to the cloud. Yeah, if but it's like depending on your technology, your skill set, if you're a performance testing background, I would that you would know performance testing tool, you would know about JVM tuning, performance tuning, um, right? You would know database tuning, or if you're a QA, you would know the functional automation testing, right? If you're operations, you would know about the support. If you're into system admin, you would be doing the installation. That's fine. But I don't expect you to know this. We take it from scratch, zero. Okay. We talk from the cloud perspective. We talk about Linux in this course because see, I would ask you one question, friends. What do you think? Where the 95 to 98% of the deployment? I would say I should say 99%, okay? But I'm just playing 95 to 98. Where do we deploy things? In Linux or Windows?
Linux.
And what I've observed over the years, we are not comfortable with Linux. Let's say if I ask you in Windows, okay, open a notepad, search for a text, replace that text with a certain word. You would be doing that. It's very easy for you to do, everybody to do, because we have been using Windows. If I do Control H, we can find it and replace it. What if I ask you to do the same thing in Linux? First of all, people will struggle. How do we launch Linux server? How do we log into the Linux server? Then how do we do that? So what I have observed, friends, uh, we are not comfortable. Okay, I'm not saying about all, but it has been my experience that we don't know much about it. Okay, so we need to be comfortable. Okay, that's one of the prerequisite of being a cloud performance engineer, or you're trying to be an SRE engineer or a DevOps engineer. You need to be comfortable with Linux. Okay, so we talk about Linux in this course. Again, from scratch. Everything is
In this
hands-on.
Linux advanced will be there, sir.
Okay, I'll come to that. How much and all, we'll come to that. Okay. We'll come to that. Just give me 15 minutes. Give 50 minutes, okay. Just just note down your question. I'll come to that, okay. I'll walk you through what all we cover. Now, we talk about the architecture perspective, microservices and monolithic. What it is. Microservice architecture. How it is, how is it different, right? And then we talk about Docker, Kubernetes, all the containerization. Okay, you may not know this, that's fine, but it's all about the containers. This part, Docker, Kubernetes is this part, right? We cover here. How do we deploy? And every discussion on the cloud, on the Docker, on the Kubernetes is from the performance and reliability. We discuss everything. Okay, all the topics that I'm listing right here, we cover in a very different way. We cover from the performance point of view. How do you tune? If you talk about cloud, always performance optimization. We always talk about reliability. How do you make sure its application is reliable? We talk about high availability perspective. How do you be highly available? See, what do you expect from an application? We expect the application to be highly available. Make my trip, Flipkart, Amazon.com. What do we expect? We expect the application to be highly available. We expect the application to be performing, reliable, security, and cost optimization. So all these discussions have been done in a very unique way of these things. That is the point. Because that's where it is an SRE performance engineering course. That is the reason. Because we discussed from all these angles, all the topics. If it is Docker, performance point of view. I'll let you know what is Docker Kubernetes, but how do you do auto scale? How do you be reliable? Right? From those perspectives, all the discussions. Now, on the DevOps part, we cover, friends, Jenkins. we talk about Jenkins, and we talk about CI/CD pipeline. And we talk about continuous performance testing in DevOps. How do you do continuous performance testing? How do you create a performance job? Similarly, you can also relate to your QA engineers in DevOps. How do we do this? The role of how do you create performance job? How do you create CI/CD pipeline? We discuss all these things, friends. We talk about from the cloud perspective. We talk from the database also, cloud database perspective. Cloud database. In the cloud, it's a totally different thing. Okay, let me ask you this question. Everybody must be having database, right? Wherever you work. How do you deploy cloud database? Do you deploy in the VM or do you use the cloud managed database, or you don't know? Three options. Where do you use cloud?
Yeah, I know that it is on VM. I know that, but for
VM.
others, I'm not.
Right. For the it's a VM, but it's a in the VM in the RDS. Okay, Swapnil use RDS. It's a relation, it's a managed database. Good, Swapnil. So we talk about this. One of the database RDS we talk about here in this course, Swapnil. Swapnil use RDS, which is the managed database offering. And it's totally different. Then how do we deploy in the VM? Okay. In the VM, we have to install database. We have to make sure database is highly available. We have to do backup ourselves. We have to do the auto. We have to make sure that the database is never out of disk storage. For high availability, we have to take care. For performance, we have to take care ourselves. But if you use cloud database, most other things will be done by the cloud. And that's what we'll focus on, the cloud part. And in the cloud part, we cover a lot of things. We'll talk about this. I've shared the link. You can go over it, what all we cover. And I'll walk you through, friends. I'm just trying to give you a high level, first of all, and then I'll go in detail for each other topic. What all we cover and how do we cover. We cover Java performance engineering in this course to help you understand the troubleshooting. See, for the SRE engineer, what is required? And how the SRE engineer is different from the performance engineer. SRE, how SRE engineer are different from DevOps engineer. There are clear-cut difference is there. Performance engineers we mostly work in the lower environment. We try to replicate the load of production, and we try to check whether the code has issues or not, and we try to figure this out. DevOps engineer is mostly do with the deployment in various environments. Primary job of a DevOps engineer. Code is ready. They will build the code and they will deploy in the QA environment. QA environment, if that issue is fine, they promote that code to higher environment and eventually to production. SRE engineer role is to make sure that the application is running healthy in production. So we should be very good at troubleshooting because there could be different issues in production. That is why it's a very dynamic, challenging role of being an SRE engineer. It's all about the customer expectations. See, when the code is deployed to production, we don't care, right? Most of the performance engineers, okay, let it go to production. We have given the sign off, looks good. Response time is under the SLA, we are good. But there could be different, we cannot simulate every scenarios in our environment as a performance engineer. We all know this. There could be different issues in production that we get. And we need to troubleshoot those issues. That is what we need to have very good at troubleshooting mindset. And that's where this will be very helpful because still most of the enterprise application is in the Java technology, and we should know how do we troubleshoot Java application. And the cloud knowledge, the infrastructure knowledge. If you have issue with the infrastructure, your cloud knowledge will be very helpful. If the application is deployed in Kubernetes, if you don't know Kubernetes, how will you troubleshoot things? Even for the performance engineer to test in lower environment, if you don't know Kubernetes, let's say, how would you performance test it? First of all, how do you do capacity planning? Because as a performance engineer, we should know, right? We should do the projection. Okay, I don't have the full production load, production in infra. I have 50% of the prod infra. I'm running the half the load. If this looks good, we can say we can extrapolate and say, okay, for production load, we would require double the infra. So that's what capacity planning is required to do. And one of the important role of an SRE engineer friend that we should be very good at observability, monitoring. But that is where we get the stats, right? We get the metrics, response time, throughput, errors, exceptions, status code. We should be very good at troubleshooting, observability. So we talk about three tools here. We talk about CloudWatch here in this course. We talk about Prometheus and Grafana. And we talk about Elastic Stack in this course.
Roshan, how about Splunk?
This is what we cover. There are a lot of performance tests. There are a lot of observability tools. There are hundreds of tools, but this is what we cover. And if you know Elastic Stack, you would be able to work on Splunk. Because both are log analysis tool. One is open source, Elastic Stack is open source, Splunk is your commercial tools. Right, so we focus on the open source technology here. That is what the most of the demands are there. Because once you know open source, you can easily work on managed services because they have a lot of documentations, lot of support. So if you know the open source, you can easily work on any commercial tools like Dynatrace, Datadog, New Relic, AppDynamics, Splunk. So that's where we focus on the open source monitoring tools.
So as
So
part
from
of
the
DevOps, Git and GitHub will be covered, and how depth will it be covered?
Okay, Git and GitHub we have not covered here, not covering as part of this, but I'll tell you, we cover how do we promote the code, how do we push the code to GitHub repository. We cover till that much. Okay. So I expect that you should know that, but if you don't know that, we cover up to see GitHub itself can take 10 hours, 20 hours. Okay, 10 hours for sure. We don't have. I'll tell you about the timing of this course. Okay. Uh, we cover up to how do we push the code to GitHub. And there are a lot of features about GitHub. We don't cover all of the features, but if you have a question, we can take it up. If we all need, let's say you enroll and let's say everybody asks for GitHub, I don't have any problem. We can take it up. Okay. Friends, on the automation. Go ahead. Let me come. Can I complete this? Can I take your question later? Can I take it? Just let me complete this part. I'm not done with the course topic. I'll take up your question. On the automation part, friends, we cover Terraform and Ansible. These things are required for the infrastructure automation. And this is to configure the configuration management tool, we call it CMT, and this is the infrastructure as code. Okay, we cover Terraform and Ansible. If you know, see in production we have so much of servers, right? So much of load balancer, databases, so many servers. We don't do all these things manually. We leverage Terraform, right? So we'll talk about Terraform. We'll talk about Ansible in this course, right? Friends, let me just walk you through. So this is the entire topic we cover, friends, in this course. And this course, this takes approximately 3 months. Okay, 3 months it takes. We will meet over the weekends, 1.5 hours to 2 hours, right? We cover 2 hours at 7:30 to 9:30 weekends, 2 hours Saturday, 2 hours Sunday, and it will have 40 to 45 hours of live sessions. And we have split this into two categories. One is live and one is recorded. So because if not, the course will go for 6 months. So this is a recorded session here. We provide my recorded session. Earlier we used to take it live, but if I used to take 5 months, people used to get bored and people wanted to know I would like to learn ourselves early. We provide recorded session. If you have any question, we can. So these two are recorded. Everything is live sessions. Okay, my recorded session only. Okay, let me give you a brief, friend. So on the cloud part, if you come here, we cover all these topics. Okay, I'm not going to go over each of the topic. It will be overwhelming for most of you, but it's enough to call yourself a performance engineer, cloud performance engineer, SRE engineer, or a DevOps engineer. Enough. Okay, this much I can tell you. You'll understand when we start on the topics. Linux part, somebody is asking what do we cover? So we cover this much. All the basics commands with the shell scripting. We cover shell scripting also. Basics of shell scripting we cover. How do we do performance monitoring, shell scripting we cover. And all the basic commands we cover. SRE concepts I have missed to highlight there. We cover SRE concepts as well. Okay. Architecture part, Docker, Kubernetes, Hive, like everything, whatever you require, ingress, auto scaling, right? This is the Kubernetes part. This is the Docker part. We have the DevOps part here, covered here. We cover Git and Docker Hub also, right? We cover this. No, this is the how do we gain resiliency? It's a part of the course. We talk about observability here. Java performance engineering, I just talked about. The automation, Terraform and Ansible, shell scripting, anyway we cover. And these two we provide, the core Java and Python, just a record. It's not my record, just a bundle, okay? People have asked for it in the past, so they would like to go for learning some coding and all, we provide this. The core Java, if you want to be a cloud performance engineer, performance engineering, Java would be required. If you want to move to DevOps or SRE, Python would be required. Okay, so you can these two are not my recording. Okay, it's somebody good at Isha. We have they are these recordings of them. Okay. Right. So this is about the course syllabus, friends. Go ahead with your questions. You have the link with you. You have the course details with you. If you have any question about the course, please go ahead. Yes, Hari Prasad, go ahead.
Yeah, see, we met before 2 weeks back in a different demo session. You said it's weekend session is coming on by August. So I'm a project manager for SRE. Actually, we are planning to migrate from LoadRunner to Jmeter, and from in server, we are planning to move it to AWS. Will this course be useful for me,
We
or?
don't talk about Jmeter here, right? I think you should be clear.
Okay.
We don't talk about performance testing tool here, right? We talk about engineering here. We talk about how do we tune from the infrastructure side, from the cloud side, from the Java performance engineering side. So if you look at the course, we have not mentioned Jmeter here. It's a different course. You can take it up from Isa itself. It's not a performance testing tool. Jmeter can itself take 40 hours, 20 to 30
No,
to
no,
30 hours, right? Go ahead.
yeah, I'm not talking about Jmeter course here because I was just explaining my current situation. This is what we are
Okay.
going to do as a project manager. I need to monitor all this. So, will this course be helpful for me because we are migrating to AWS from on-prem servers? I'm sorry.
Yeah, definitely, right? We cover AWS in detail here. And you may be deploying in the VM or in the kube container, I'm not sure. But if you're deploying on the Kubernetes, this will help you. You will be also adopting DevOps, CI/CD pipeline. right? And you would be also doing tuning, right? So all the things you would be also doing monitoring, all the things is what you would be required.
Okay.
I see a question from Madhvi. Does this course include practical challenges in the real world? Everything is practical, Madhvi. 80% you will always see me with issuing some commands. Today I'm just talking. You'll always see me with the cloud environment. Everybody, friends, we will all have this cloud account. Everybody, whoever gonna enroll with in this course, everybody is going to have this cloud account. Everybody. We will create servers, we'll create services. We have so many services to cover. We covered 20 to 25%, 25 services, important services. We have so many services. You will always see me with the black screen, issuing command, deploying servers, doing this, doing that. Right? You'll always, it's 80% of the hands-on. And I'll explain the theory from the commands itself. Like, okay, if this is the switch, we'll do this. So it's mostly the hands-on sales. We believe on the learning with the hands-on doing. And you're supposed to practice all those things. You may not be able to do along with me. If you have two monitors, you can do this. We go slow, but you're supposed to practice before we meet the next session. That's why you get the entire weekdays to practice it. Because if you don't practice it, you will forget it. And we make sure that you know what was covered before. So that's where it's a complete hands-on course to answer you, Madhavi. Interview questions, yes, we do provide interview. See, once you go over the topics, right, you would be able to uh, go over the Google it and go for interview question, and you would be able to answer it. That would be my thing, my agenda. Me providing interview questions, that's fine, but you would be able to answer the interview question. That's more important. So I'll focus on that part. Swati has a
Yeah,
question.
and also I would like, sorry,
Go ahead. Go
Hari
ahead. Go ahead.
Roshan, I would like, yeah, Madhavi here. So I would
Yeah.
like to add one more question. So since you said perform SRE or anybody would be focusing on the production monitoring as well. So why can't we include a chaos engineering in this course
Yeah, we
as a
have a module.
prerequisite
Okay,
step?
so we do have a module of chaos engineering. We talk about chaos engineering. Okay, it's not a hands-on part, but it's a part of the SRE concepts. Okay, because anyway we cover from very scratch in 3 months. Okay, we do have chaos engineering here. Okay, as part of this, and I explain you how do we do a chaos engineering? How do we go about chaos testing and engineering? We do cover this. It's there in the course as part of SRE.
Okay. Yeah. Okay.
Okay.
Thank you.
Sure. I'll just show you what all we're gonna do, friends. Okay, let me show you first. Okay, so this is the repo where you would be given access to. Okay, where you have all the documentations, PPTs. This repo. We have the cloud part. We have the Linux part. We have the Docker part. We have the Kubernetes part. If you go inside this SRE module, you have the DevOps part. You have the performance engineering part, Java performance engineering. You have this, right? And I'm going to share a lot of documentations, books with you, along with the session, uh, live sessions, the recorded sessions. I told you all the books on the Java performance. It will be very, very helpful for you to understand how do we go about tuning Java applications. Okay, let me go over the one by one. So on the cloud part, friends, if you look at the depth that we cover, okay, we go over all the slides. We have approximately 150 slides. Okay, it takes a lot of time for us. Okay, we cover a lot in detail. Okay, on the Linux part. That's why we have split few things on the recorded, few on the live. Most of the on the live Linux part, we cover each and everything here about each of these commands. If you just go over the command line, and I will practice these things, all these commands. Okay, along with the shell scripting. Once you have the basis covered, shell scripting on the Docker, Kubernetes, microservices, friends, we have. Let me just go over it. So Docker, we have this here. What is containers? How do we create containers? How VMs containers are different? What is the underlying technology? How do we create containers? Docker container lifecycle. How do we go about Docker architecture, and how do we create containers? How do we create images, Docker images? Everything. Okay. On the Kubernetes, what is Kubernetes architecture? What it is, HPA, how auto scaling works, what is pod, replica set, deployment services. You may not know this terminology. I don't want to go in detail right now. Just high level, you would know how do we auto scale in Kubernetes, right? Every detail you have it here. Okay, how Kubernetes architecture works. So how do you load balancing works, how HPA works, how do we monitor things in Kubernetes, right? So you have like auto scaling HPA, how it works. So you have a lot of details here. On the SRE module, as I was telling you, we have chaos. We cover the different technology that we have, okay? And the chaos engineering that we have, we cover it. What is chaos? Also, Madhuri, just to show you. And cloud databases we cover cloud databases, which I was explaining you. On the DevOps part, we cover CI/CD pipeline, uh, eliminating toil, Ansible, Terraform, we cover here. We have the observability, the monitoring part. Okay, we cover Prometheus, Elastic Stack, we cover. Okay, so this is the entire thing we cover. Okay, this is what we cover. Uh, and this is what takes long. Okay, this takes long, and it needs commitment from your side also. Okay, please be mindful. If you are committing, please commit an hour with me. Okay, we will meet over the weekends, but you need to practice on daily basis, Monday to Friday, weekends. You have to commit an hour daily. Then only please enroll. Take a decision. Okay, I don't want you to just come, listen, forget. No use, right? Please commit for an hour and then enroll, because it's going to be quite a learning session. Yes, Prisha, go ahead.
Yeah, hi. I'm from a QA background and I don't know anything about DevOps. So will this be a beginner course? Like I saw you
Okay,
you
do you
explained
want to
everything.
transition to DevOps, Prisha?
Yes.
Okay, so this is absolutely a DevOps friendly course. Okay, AWS is covered, Linux is covered, Docker Kubernetes is covered, DevOps is covered, observability is covered, Terraform Ansible is covered. You have few things which somebody highlighted, Git in detail.
Mm-hmm.
I can just cover the GitHub in detail, and that's it.
Okay.
Entire DevOps course is here.
Okay. So it will be easy or like how will it be for me to transit from QA to DevOps?
See, first of all, I will make it easy. That's on me.
Okay.
But you will have to work hard. That's on you.
Yes.
I cannot commit on your part.
Uh-huh.
So you need to make your mind. Do you really want to do that? Because it needs commitment, an hour and 2 hours from you on daily basis for next
Okay.
3 months. If you do this, it'll be easy. If you just
Okay.
listen to me and do and will not and just will not practice it, I would not be you. It will not be helpful. So you need
Okay.
to commit hands-on, because this is a hands-on session and I expect people to do hands-on, ask me questions. You and me will be in WhatsApp group like this, and you were supposed to ask me questions. There are batches going on. If you see 7:30, we have this morning weekday batches uh, going on, this batch, and we have another batch, and we just wrapped up the other two batches also. So we have, I will be in this WhatsApp group along with you, and you're supposed to ask questions and practice it, friends. The recorded session will be provided on daily basis. I'll just show you about this. The recorded session will be given on a daily basis like this. And it will be a lifetime access. You'll be like right now we are recording. Similarly, we'll be recording on daily basis and you'll be recorded and you're supposed to go over it and practice it um, for everything, right? For this is for our live sessions. Same thing. Records will be given for the Linux. Linux would be given 3.5 hours of Linux is enough. We don't cover a lot to confuse everybody. What is required? Uh, Same thing for the performance engineering. Okay. Uh, 10 hours of 10, 11 hours of recorded sessions is what we cover. Right. And same thing for if you Java and Python, you would get it anyway. Both. So it needs commitment. So that's what,
Yeah.
Trisha. So if you're committing,
Okay.
it will be an easy journey.
Yeah, sure. Thank you so much.
Sure. Yeah. Anybody? Yeah. Pradeep, go ahead.
Yeah, so I belongs to the Microsoft Dynamics 365 product implementations and related performance and all. So as part of observability, so is there any one single session you can give on the Azure application insights, like monitoring stuff?
Yeah, I used to do that, but since I working mostly from last 4 years, I'm completely into Azure and GCP. Okay, so I don't have even the. I need to check. I can give you. Okay, that's I can need to create the account once, and I can do this. Yes, it very
Okay.
much. See, I'll tell you, Pradeep. I'll show you CloudWatch. Okay, you will gonna find yourself Azure Insights. It's
Yes.
same. It's
Mm.
same. Every cloud is same.
Okay.
Use case, see, server, we get the server. You get the server in AWS also, in Azure also, in GCP also, in any other cloud.
Yeah.
Storage. Why do we use
Yeah.
cloud? We want to get the server.
Yes.
Look and feel will change. The UI changes, but the use case remains the same,
Okay.
right?
Yeah.
Storage. You would call S3 in AWS, call blob storage in Azure. You call object storage in GCP. The name changes. I will show you about the CloudWatch. Let's say if I give you, which is the AWS in-house monitoring service. Okay, you're gonna find that yourself. You create the server, you would see the metrics there.
Okay.
That's how I see these things. I'll
Perfect.
walk you through, I'll make you very much comfortable. That's how even I have learned all the cloud four. Nobody has taught me all the cloud, all the four cloud. I've learned one in the beginning, and then I slowly picked it up, all the four. It was one and the same. It's like if you know one performance testing tool, you would be able to figure out how to work with other.
Correct.
That's how it is.
Yeah. Perfect. Thank you.
Sure. Okay, I see a lot of questions. Let me just read it. Friends, feel free to unmute yourself, but let me just read through it. I have Mahesh. I see. I have 4 years experience in performance testing in Jmeter. Zero about coding, so performance is required. See, Mahesh, performance engineering, what it is, you should first define it. It's all about tuning. Tuning could be from the application code perspective. Is Mahesh there? Mahesh here online? Mahesh, you there? Yes, no? I'm answering your question, Mahesh. Okay, anyway, I'll take this question. See, tuning could be on multiple layers. Could be from the infrastructure tuning, could be from the code, Java code perspective, could be from the database. So if you're talking from the code perspective, you don't need to know coding like a developer, but you should know basics, cloud, what is classes, what is objects, inheritance, encapsulation, abstraction, just basics so that you can talk to developers. Because if you take a heap dump, thread dump, if you don't know about the methods, classes, objects, how will you talk to the developer? So know the basics. You don't need to be a developer, but you should know at least the structure of a Java code. How do we write it? High level, right? You may not know the logic very much well, but you should know how a Java program looks like. We have what is oops concept. You should know that. Same thing for database tuning. You should know how to tune the database. You may not know all of them, but we have to learn it, right? Same thing for infrastructure tuning. We will talk about a lot of things from the infrastructure tuning, from database tuning in the cloud. That's what we will learn here. So if you look at the course, we are talking from the infrastructure tuning, from the Kubernetes infra, cloud infra, right? And then from the Java code perspective. So we are covering anyway two things. So it's not very much required to be a developer, but you should know high level understanding of those things. Okay. Yes, Swati, you can take the recorded session. That's possible. Okay, I see question how many years experience we can mention post this training. Okay, I can cover up to 3 years. Okay, if you practice hands-on, Swati, everything in this course, 3 years you can easily justify. Okay, Swati there. Okay, I see. Would you be learning only AWS? Would be also work on different? Okay, different. Fustina, are we already covering 3 months here? If you talk any other cloud, right, it'll go for 6 months or 4 months. If we can keep on adding topic, because look at the depth and breadth that we are covering. It's quite immense. And we're able to do this in 3 months. It's itself a challenge. But don't worry about multiple cloud. Learn one cloud well. That is more important. I can take a session on Azure. I can take a session on GCP or any other cloud. One and the same. Okay, just focus on learning one cloud better. That's how I would say, Fustina.
Okay, thank you.
Perfect. 2 hours a week would be sufficient to complete course. So please, that's what we will do. Okay, that's what we have been doing. All these things. Okay, over the years, we will be doing this. Swapnil. So, and in the simplest manner, I know what you're thinking about how it's possible to cover these many topics. And I'm telling you, we'll cover that in the simplest manner anybody can understand. I don't expect you to have any prerequisite knowledge, I'm telling you. And that's how we'll take it up from very scratch. What is SRE opening in the current market situation? Oh, check this. Go to LinkedIn and check it. Why to ask me? Go to LinkedIn. Okay. Go to jobs. Search SRE. Okay. That's it. Search for your job. Where is the job? Okay. Okay. Is this enough proof? Somebody was asking. So, you good?
Yeah. So I have one more question. So if you can allow me to do that. So what about the projects? Means how would you be showing some projects so that we can leverage those projects
Everything is
into our
hands-on. That's what I'm
resume?
saying to you. Every day is going to be a project. Every day is going to be a project. It's not like a web application we will set up, right? Every day is going to be a project hands-on. So we'll have applications deployed in the server. I'm going to show you do things. Kubernetes cluster, I'll create it. I'll deploy microservices. I'll show you. We'll create pipeline. Every day is hands-on. Every day is project. It's a complete hands-on course.
Oh, okay. Yeah. Thank you.
Okay. What is the other question? If you're able to attend the weekend class or only records, yeah, you can do, Swati. You can do this. See, only thing with problem with recorded session, right? People think recorded session is good. I'm not denying that. If you can maintain a discipline, that is where the problem is. Because I have myself faced the problem. I can take any course, but do I have the discipline to learn? That is the most important thing. You should answer this question. So with the live sessions, you get a discipline of attending the session, practicing it. That's what this makes it different. Okay. And that's where the commitment is important. And that's how it's different from the live sessions. Okay. That's why different is in live session than the recorded session. Okay. So you can get it. You can get we have all the recorded session. We can get it. So that's not a problem. Okay, I see a question from Mirali. Basic entry job available for SRE. How many years experience typically required? See, you can, okay, US, Canada. See, you can try to be a cloud engineer first, basic engineer, basic entry role. See, SRE is all about 3 levels, okay? L1, L2, L3. You need to understand one thing, very, very important question you asked. SRE role is classified into 3 categories, L1, L2, L3. L1 are the junior folks, support kind of role. They work in the shift 24/7 and they would let to know. Let's say company like Flipkart, any retail website, retail company, Amazon, Walmart, right? 24/7. You have so many retail websites, companies. So they have to be support engineers, cloud engineer or support engineer, I would say, cloud support engineer. So they have to work on shift so that if they can monitor things, and we should have alerting setup. That's one of the important things about observability. We have to have the right alerting setup so that we get alerted and they can take action. L2 is what we prepare for in this course. L2 is the senior guys who help us create the dashboard, set up the dashboard, set up alerting, observability, alerting, give SOPs, standard operating procedures. What would you do if the issue comes in? What would you do if the response, if the customer comes about high response time? What would you do if the status code, if you get so many errors, 500 status code, what would you do? What all will you check as part of troubleshooting? What all capture you will do? So they have to write some SOPs. And that's what we prepare here, L2. L1 already we cover. If you cover L2, L2 is all L1 is already covered. So you can try for the L1 as a support as a starting role, but we try for L2. If you have comfortable enough to troubleshoot things good at this, try for L2. And it's their SMEs. This will take some time. Okay, to be an SME, you need to have a good product knowledge as well. Okay, in and out of the product knowledge. So when L2 engine is
So
called
are we
L3.
covering
Go
are
ahead, go
we
ahead. Ask.
covering L1 and L2 here in this course?
Yes.
Okay.
Lot of all the responsibilities I told you, right? Troubleshooting, optimization, infrastructure tuning, all this knowledge. Why do we require this? To be L2. That's why we have these many things to cover. So that you can perform your responsibilities as an L2, senior SRE engineer. Okay, I see all the questions are sorted. Anybody else? Any questions? Okay, did we get the understanding, friends? Okay, go ahead.
Roshan, yeah, Seolla here.
Go ahead.
So
Go ahead.
actually, I was asking that even it can be considered as cloud architect, some course related to cloud architect, because we are covering a lot of things in cloud, right?
Yeah,
So
definitely. We will. I'll tell you. I'll answer your question in a better way. After this cloud certificate, this course, right? You can I'll guide you. Okay, I'm not telling you just with this course you'll be able to clear a certification, but upon few guidance, you'll be able to clear the associate level certification, architect associate level certification in cloud. Okay, so we cover up to 60% of the course already. I hope you know about this certification, right? Architect associate level certification. Yeah, we cover up to
means
that.
from AWS.
Yes.
So, and even because mostly we will be going for AWS, but like even we can overlap to other clouds also, right? Like Microsoft,
Okay,
Azure.
same question. I need to tell you.
Yeah.
So don't make it a big thing in your head that, oh, it's totally different. You first learn one cloud well. Please, everybody. Wherever you learn from, learn one cloud well. After that, it's easy to learn any other cloud. focus on learning one cloud. That's a simple message. So we'll focus on
In and
AWS.
out.
We cannot focus on all. Okay. I'll tell you, I'll give you one. I'll simplify this. Your lot of concerns I see. Friends, this is a very important link. This link talks about if you have a service in AWS, let's say EC2, we use this for creating the server. Because that's why we use cloud. We want to get the server to deploy my application, right? We call EC2 Elastic Compute Cloud in AWS. You have a similar service in Azure, which do the similar thing. The look and feel, the UI will be different, but they will be asking the same question. You need to mention the operating system, the core, the RAM, the disk. Here also you have to give the same detail. In GCP, you call it compute engine. Similarly, friends, all these things are similar. The look and feel will change. Okay, I'll show you one of the cloud. Let's say I have a GCP. Okay, I'll show you one of the differences. So I just want to solve this concern. I get a lot of this concern. What is happening? 1 second. When this Teams is doing this. Okay, see, this is my cloud. Okay, AWS. If I want a server, what will I do? I'll go to EC2. I'll search for EC2. EC2 is a service, stands for Elastic Compute Cloud. I'll go to the service. I'll go to the instance. I will create the server. Launch instance. I'll create the server. I'll mention the operating system. I'll mention the core and the RAM. I'll mention the key pair. I'll mention the disk and I'll create the instance. That's it. And I'll be able to connect to this. This is what we do in AWS. If you have to do same thing in, let's say, in Azure or GCP, Google Cloud. There we call it compute engine, friends. What do we call this? We don't call EC2. What do we call it? Compute engine. Go here and create VM instances. The look and feel changes, but after you go there, you same thing they will ask. Give the AMI, give the operating system, give the ROM, give the core, RAM, disk, same detail they will ask. Look at this. So this is the difference we're talking about, the look and feel difference. It's not a very big difference. Okay, is everybody on the same page?
Yes.
Same thing happens for Azure also. I have a login. I'll show you, friends, some other day. I doubt I have a login. Okay. Same thing. Okay. Very much similar. Okay. Any other questions?
One more question I have, because we are going to practice Linux also, right? So
yes.
if I have Windows, like I have laptop on Windows, like I have Windows operating system on my laptop, so I should I should have one different instance. I should launch some instance.
Yes, we will launch instance. Correct. You don't need to do anything in your laptop. We will create the server in the cloud. We will connect to the server in the cloud and we'll practice it there. Don't worry. We will not touch your laptop. Even I have a Windows laptop. I have a Mac. Right now, I'm in my Windows laptop. Doesn't matter. We will not do anything in your laptop.
Yeah, so maybe I need to have a separate laptop, because in my current laptop, I was checking that I don't have access to AWS server. So AWS,
nothing like this. Nothing like this. Okay.
No, maybe it is company laptop, so it can be.
That could be reason. I don't know. Check this website. Can you launch this website? aws.amazon.com. Does it work there in your laptop?
For me, it is not.
Then it's a firewall thing. Yes. So yeah, use personal laptop. Yeah, get it, friends. That's if this website doesn't open, I cannot help that. Yes.
Hi, Roshan. Just one question. So we can use putty, right? SSH, and then we can do it.
Yeah. We will do. We'll
Yeah,
use
yeah.
putty just a client. We will
Yeah.
use mobile extern. We will learn multiple ways to connect.
Right. Thanks.
We will use Windows command prompt to connect. No need to use putty also. We'll use
Okay.
command prompt.
Thanks.
We'll do SSH command here. I'm going to issue commands here. SSH command in the command prompt. Windows command prompt. I'm going to issue this command, SSH command, and we'll connect to the server. If you have Mac, you can use terminal. If you have Windows, you can use this. You can use putty. You can use mobile XTerm. There's so many clients available. So we will learn everything step by step. Okay, friends, any other questions? Okay, perfect. Thank you so much, everybody. Let's meet tomorrow and start our day one agenda. Thank you so much.
Thank you.